Hey guys, if you're here because your part 2 is overflowing or taking forever or just straight up crashing, what you want to do is head over to timestamp 718. Day 11, let's go! Monkey in the middle. As you finally start making your way upriver, you realize your pack is much lighter than you remember. Just then, one of the items from your pack goes flying overhead. Monkeys are playing keep away with your missing things. To get your stuff back, you need to be able to predict where the monkeys will throw the items. After some careful observation, you realize the monkeys operate based on how worried you are about each item. Okay, you take some notes, your puzzle input, on the items each monkey currently has how worried you are about those items, and how the monkey makes decisions based off of your worried level. For example, monkey 0, starting item 79.98, operation new equals old times 19, test divisible by 23, if true, throw to monkey 2, if false, throw to monkey 3. Okay. Are they always going to be divisible, some calculus or calculator operation, throw, okay. Each monkey has several attributes. Starting items list your worry level for each item the monkey is currently holding in the order they will be inspected. Operation shows how your worry level changes as that monkey inspects an item. Okay. An operation like new equals old times 5 means that your worry level after the monkey inspected the item is 5 times whatever your worry level was before the inspection. Test shows how the monkey uses your worry level to decide where to throw an item next. If true, okay, and then if false, then what happens if it's false? Okay. After each monkey inspects an item, but before it tests your worry level, your relief that the monkey's inspection didn't damage the item causes your worry level to be divided by 3 and rounded down to the nearest integer. What? Inspecting and throwing items. On a single monkey's turn, it inspects and throws all of the items it is holding one at a time and in the order listed. Monkey 0 goes first, then monkey 1, and so on, until each monkey has had one turn. The process of each monkey taking a single turn is called a round. When a monkey throws an item to another monkey, the item goes on the end of the recipient monkey's list. A monkey that starts a round with no items could end up inspecting and throwing many items by the time its turn comes around. If a monkey is holding no items at the start of its turn ends. In the above example, okay. After round 1, the monkeys are holding items with these worry levels. Okay. Monkeys 2 and 3 aren't holding any items at the end of the round. They both inspected items during the round and threw them all before the round ended. This process continues for a few more rounds. Chasing all of the monkeys at once is impossible. You're going to have to focus on the 2 most active monkeys if you want any hope of getting your stuff back. Count the total number of items each monkey inspects over 20 rounds. In this example, the 2 most active monkeys inspected items 101 and 105 times. The level of monkey business in this situation we found by multiplying these 1065 or 10605. Figure out which monkeys to chase by counting how many items they inspect over 20 rounds. What is the level of monkey business after 20 rounds of self-slinging simian shenanigans? Okay. Okay, today's bit of code took a bit of time. I only really got caught in one little thing, which we'll get to in a minute, but just chopping down the video enough to make it fit is just going to kill a bunch of stuff. So I'm just going to walk through the code and kind of explain what's going on. So the first thing we have on here is we have a class monkey, and this is basically all the information that we can get from a monkey from the input. Then we have an operation function, which basically lets us do the operation. There's one little trick because some of the operations will be old times old, and so we have to basically keep track of that as well. And then if it's a throw item, basically we do the test and figure out which monkey to throw it to. Also a parse function. This is very similar to how we've done parsing the last couple weeks. And the only difference is there's a bunch of different little things in here because we have to parse every line slightly differently. I'm not going to get into that. So if you want to check out the code, it's in the GitHub. Okay, so part one then basically is we can just parse our input and get our list of monkeys. And then for each turn, for each monkey, for each item that monkey holds, we're going to get our level of worry, divide by 3, and then figure out which monkey we should throw to based on our worry. And then that monkey, we need to add that item, and then increase the number of throws for the monkey that we're currently looking at. Just to make it easier, since each monkey finishes throwing all of their items before we move on to the next monkey. Once all the items have been dispersed, then it's clear out the whole list. I don't worry about trying to mess with the list while we're iterating through it. Makes it a lot easier. To get our answer then, it's pretty simple. We just have to take the monkeys, sort by descending by the number of throws, and then take the top 2, multiply them together. Easy enough. For part 2, it's reading it. The only 2 differences are going to be that instead of doing 20 rounds, we now do 10,000 rounds. And we no longer divide our stress by 3 every time. Instead, basically, you just can ramp up as much as it wants. And then other than that, everything's fine. Since the first time I was reading through this, I was like, oh, well, this definitely sounds like something we should be using longs for. I was like, okay, great. I can just go ahead and make those 2 changes, and it overflowed. It overflowed by a lot. So I went through and I changed everything to big ints, because with big ints, you can make the number as big as you want, as big as you have memory for. And it was taking a long time. Like the first couple thousand iterations went through pretty quick, but it started really bogging down. And I have a very fast computer, but when big ints start getting into the millions, hundreds of millions of digits, things just start to take a lot of time, and it's just going to keep getting bigger and bigger and bigger. So obviously, if this is a puzzle, there had to be some sort of neat little trick to get around that, which basically is probably why you're here. So what I did is we don't care about the actual value of our stress level. We only care if the stress level is modulo by some certain value for each monkey. The problem is each monkey has their own value that they check for. So instead of trying to determine those independently, the easiest thing to do is we'll just take a product of all of them. So I have max stress, and then for every monkey's test value, I'm just going to multiply it. This is going to give us a product that is basically all of those test values together. And then if we are above that, we can just take that whole chunk out, we just module that whole chunk, and we get a new value that's much smaller, and it's basically the same for our tests. Like, we don't care about the actual value, we only care about the remainder. So if we can take all those out and leave the remainder for all of them intact, then we're doing good. And once I did that, the whole thing took only like a second or so to run, and that's it. Anyway, so a little tricksy on that second part, but I will see you guys tomorrow.